folks, welcome back to part 2 of Solve Problems Involving Proportional Relationships, Chapter 1, Section 6. This should be the last video of Chapter 1. Yay! Elisa's class is making care packages for a local shelter. They can make 8 care packages with 240 items. How can they make care packages? How many care packages can they make with 510 items? You need to take and pause the recording and use one of the many tools I have shown you as the resource in order to solve this problem. Do that at this time, please. Did you get it done? Which method did you use? Did you use a ratio table? Did you use a double line graph? Or maybe direct variation, which involves algebra? Given a choice, I'm going to jump to algebra every single time because algebra makes the world so much easier, so much quicker. It's nice and concise. So I'm going to start off with my direct variation equation that says y is equal to k times x. Now my y value is going to be my 240 food items. My x value is going to be my 8 care packages. And if you think about it, 8 times some number of items equaled 240. So I'm going to put my 240 in for y. I'm going to put my 8 in for my x value with the time symbol there. And now I have my initial direct variation equation. I'm going to isolate my variable. The variable's k. His friend is 8. 8 is multiply itself times k. So I'm going to divide by 8 on both sides. If I do it on the left, right, I have to do it on the left. 8 divided by 8 becomes 1, and 1 times k, well, that's just k. And from there, I can say, all right, k is equal to 240 divided by 8. That is going to be 30. Now, that is not my final answer, but it is an important sub-answer. And from here, we're going to take and move on to the very next spot where we're going to go back to that y equals kx formula, only now we're going to plug in what we know. We know the target is 510 items. We also know that k is equal to 30, and we need to take and find out what x is. To do this, once again, we're just going to isolate the variable. I'm going to take and divide by 30 on both sides, just like that. 30 divided by 30, well, that's going to equal to 1, and 1 times x is x. Now, 510 divided by 30, that's pretty tough, but watch this. Anytime you have zeros on the end, meow, those zeros are now gone. So now all I have to worry about is 51 divided by 3. So 51 divided by 3, 3 goes into 5 once. 1 times 3 is 3, with 2 left over. Bring down the 1, 3 goes into 21. 7 times, 7 times 3 is 21, with nothing left over. So what does x equal? X is equal to 17, which means that we can make 17 care packages. We're going to take and go back to our problem page, which is right here. We're going to type in our 17, and we're going to check our answer. Excellent job. Is that what you got? I sure hope so. Here's the new problem. After 2 hours, the air temperature had risen 6 degrees Fahrenheit. The temperature is forecast to continue to increase at the same rate for the next several hours. At this rate, how many hours will it take the temperature to rise an additional 13 degrees Fahrenheit? Well, let's see. Think about it. A classmate said that the number of hours the temperature rise, the additional 13 degrees Fahrenheit, is greater than 4 hours. Is that true? Well, how do you know without calculating? Just doing a quick rough estimate, it took 2 hours to rise 6 degrees. So if I doubled 2 and doubled 6, that would give me 4 hours and 12 degrees. We're still not at 13, so yeah, it's going to take more than 4 hours to be able to get to 13 degrees Fahrenheit. That's some important things to think about, because that's your stupid check. When you're done with a problem, you think, okay, does my answer make sense, or did I make a stupid mistake along the way? Let's move forward. Choose a strategy for solving this problem. for this problem, using an equation is an advantageous strategy because the calculations with fractional values are going to be involved. You know this because there is no whole number which you can multiply 6 by to get to 13. So, using the direct variation equation, that's going to be the way to go. Like I mentioned earlier, I'll take algebra any day of the week over having to draw pictures and number lines and stuff like that. Move through the slides to find the unit rate involving the equation y equals kx. If you see right here, they took, and just like we've done before, they wrote the original equation. Then they said, well, it takes 2 hours to rise 6 degrees. So your degrees is your y value, your time is your x value. From here, they isolated the variable by dividing 2 on both sides. After they divided 2 on both sides, these 2's divided out becoming 1. 1 times k is k, and 6 divided by 2 is 3. So now I've got my constant of variation of 3, my k value, and I'm going to take and move forward and plug that number into the direct variation equation, where we can see in this slide that they've taken that k, the constant variation 3 we just found, plugging it in right here for the k value. The target was 13 degrees increase. They plugged 13 in for the y value, and then once again they isolated the variable. So they have 3 divided by 3 and 13 divided by 3. Dividing by 3 on both sides, of course 3 divided by 3 is 1, and 1 times x is x. 13 divided by 3 gave us 4 1/3, which is a mixed number. And 4 1/3 hours, you know, that doesn't do an awful lot to explain time to us. What is 4 1/3 hours if you look in hours and minutes? Well, the 4 part is going to be the easy, 4 hours. But how many minutes is 1/3 of an hour? You have 60 minutes in an hour. What is 1/3 of 60? The answer is, of course, going to be 20. Check, boom, very good. So it takes 4 hours and 20 minutes to rise that extra 13 degrees. Now, what other strategies could you have used to solve this problem? Well, you could have used the ratio table, but that might not have been so advantageous, because if you had, you would have had some mixed numbers showing up in that ratio table, which isn't a lot of fun. And the double number line, that wouldn't have been good at all, because there's no even gaps that you could set up in that double number line to where you could make nice precise calculations. So for this one, the direct variation equation, algebra, that's definitely the way to go. Now we have another problem for you to work on. Aspect ratio is the ratio of the width to height of a television screen, or a computer screen, or the iPad screen you're watching this video on. A widescreen television screen has an aspect ratio of 16 inches wide to 9 inches tall, although most of y'all aren't using 16-inch TVs these days. I still remember my folks having a little 13-inch black and white TV when I grew up. Yes, I'm that old. Use the same aspect ratio. What is the height of a widescreen television if the screen is 44 inches wide? You pause the recording, calculate this one, and check your answer, and I'll come back and show you what I did. Now, once again, given a choice, I'm going to use algebra every time. So I'm going to start with my direct variation equation, y is equal to kx, where we're taking and comparing the width to the height. I'm going to let my height be my x value, my width be my y value. So I'm going to have a width of 16 to a height of 9. From here, I can take and isolate my variable, dividing by 9 on both sides. And when I do that, 9 divided by 9 is going to be 1. 1 times k is k. And that's going to leave me, in simplest terms, is 16 over 9. And I'm going to leave it just like that. No reason to convert this to a decimal. I will circle it, not because it's the answer, but it is an important sub-answer. Next, let's take and widen up our marker just a little bit. I'm going to take and set up my equation again. Y is equal to kx, only this time my k value is going to be my direct variation, 16 over 9. My y value is going to be 44 inches because we want it to equal 44 inches. And my x value, well, that is what we're looking for. Now that does look pretty scary, doesn't it? And we've never done anything like this, but I'm going to show you what to do. We're going to take and divide both sides by 16 over 9. So that's going to be the same thing. If you remember, division is the same thing as multiplying both sides by the reciprocal. So on the right, where I had 16 over 9, I'm going to multiply that by 9 over 16. And I'm thinking we just got an email that said that school is either happening tomorrow or canceled. It is going to be canceled. Woohoo! Yes, teachers get excited when school gets canceled too. No school tomorrow, Monday, August 30th, 2021, due to Hurricane Ida. From here, I'm going to do the same thing on the right-hand side of my problem, 44 over 1 times 9 over 16. And of course, I do still need to have my times x right there. Simplify before I multiply. 16 goes into 16 once, 16 goes into 16 once, 16 goes into 9 once, 16 goes into 9 once. That's going to end up giving me 1 over 1, or just 1 times x, which is x. So my variable's isolated. But now I can do some simplifying over here too. I can say that 4 goes into 16 4 times, and that 4 goes into 44 11 times. That's all the more it'll simplify, but when I multiply, I get 99 over 4. That's not a very pretty number, is it? I'm guessing that they're going to say they wanted us to round that to be 100 inches. Because if you think about it, hold on, something ain't right. I'm sorry, they're going to want it to be 25 inches. Because if you think about it, if I was to take here and divide 99 by 4, I would get 24 and 20, I'm sorry, my bad, I would get 25, booking up again, 24 and 3/4 is equal to x. Well, they don't have that option there. My guess is they're going to want us to put in 25 for our inches, rounding it to the nearest whole number. So let's give that a try. I'm going to type in, oh wait, no, maybe they do. So let's try it. We're going to do 24 and 3/4, except, check our answer. Am I right? I am right. That is a little bit more complex than the other problems we were doing because it does involve fractions and mixed numbers and things of that nature. That is, however, showing your work. I definitely would not want to try to do that using a double number line or even a ratio table. It would not be a lot of fun. Algebra is the way to go, and this is the way to show your work doing it. And with that, we have reached it to the apply part of our problem. It says, what are some real-world problems involving proportions? Watch the animation to find out. So let's make this just a little bit smaller, and here we go.
At a recent statewide blood drive, the ratio of type O to non-type O donors was 37 to 43. Suppose there are 300 donors at a local blood drive. About how many are type O?
So that is an example of a real-world ratio problem, and we need to take and figure out how to do that. So with that information, they're going to take and have you do your what's the task, read the problem 3 times if needed, asking yourself these questions. You're going to pause the video while you take and type out what strategies you're going to use, and then from there you're going to put out your solution, and after your solution you are going to type into words a defense of your solution. Pause the recording and work on this. So did you get an answer? This one's pretty ugly. Well, how did I start? Well, first I have to type out what I'm going to do. So what I typed is that first I'm going to use a direct variation equation to find the constant of variation. Next, I'm going to use the same equation and the new constant of variation to find my final answer. So let's see how that's going to work. We're going to start off with our direct variation equation, y is equal to k times x, where we have your x term and your y term. So my y is 43 is equal to k times my x term is 37. I'm going to take and isolate my variable by dividing both sides Hold on. No. Stop and read the question again. It says, suppose there are 300 donors at the blood drive. This is comparing type O to non-type O donors. So I'm not doing 37 to 43. I'm doing 37 to, what is 37 plus 43 going to equal to? Well, that's going to be a 1080. So I need to get my eraser going here, and we are going to change our y value to 80 because we are comparing this to the total number. So now I have 37 divided by 37 on the right, which becomes 1. 1 times k is k. And on the left, I have 80 divided by 37. And I'm not going to do a thing with it. It's already in simplest terms. I don't want that as a decimal, so I'm just going to take it 80 divided by 37, and we're going to leave it right there. Next, we're going to take and do the direct variation equation again. Y is equal to kx, only this time I'm going to set it up to where my new value, my new total value is going to equal to 300. My constant of variation is 80 over 37, and my x value is what we're looking for. How many type O donors were there? We're going to take and divide both sides by 80 over 37, which is the same thing as multiplying both sides by the reciprocal. So I'm going to get 300, we're going to change that to an improper fraction, times the reciprocal, which is 37 over 80, is equal to 80 over 37 times the reciprocal, 37 over 80. Those just divided each other out, leaving x. So we're going to get x on the right is equal to, and on the left we can do some simplifying. First, I can say that 20 goes into 80 4 times, and 20 goes into 30. I believe it's going to be 15 times. Let me come off to the side and do that. That's going to be 300 divided by 20. Well, that's the same thing as saying 30. Yep, it is in fact going to be 15. And with that, everything is simplified. Now I need to take and multiply my 37 and my 15. When I do that, 5 times 7 is 35. 5 times 3 is 15. That makes it 18. This would be a 7 and a 3. Add those up, 5, 15, and that's going to become 5 again. So I get 555 divided by 4. We're not done yet. We're going to have to do some long division. First number goes in the house. 4 goes into 5 1 times, which is 4 with 1 left over. 4 goes into 15 3 times, which is 12 with 3 left over. 4 goes into 35 8 times, which is 32 with 3 left over. So our answer is going to be 138 3/4, written as a fraction. You can't have 3/4 of a person though. So my guess is that the answer should be about 139 type O donors. Check it. We are indeed right. And once again, I rounded it to 139 because I cannot have 3/4 of a donor. So x is equal to, or x is actually about, the squiggly, 139. This is showing your work, folks. This is what I must see if you want full credit. Now, of course, you do also need to take and write down your explanation of this. I explained it as I was talking it. You need to be able to put your explanation in words, how you solved it. If you're feeling particularly froggy, go ahead and work this problem, but I think we've made enough of a point on this lesson, so I'm not going to do it with you. I'd rather you get started on your assignment at this time. Be sure to pause the recording, stop the recording, give me good, high quality supporting work, okay? If I'm not getting high quality supporting work, I cannot give you credit. If you ask yourself, what does high quality supporting work look like? It looks like that, okay? Where I'm using algebra, I'm using the direct variation equation, I'm finding the constant of variation, and then I'm using that constant of variation to find my new amount. Good luck. Look forward to seeing some perfect tens on homework.